Hi everybody, welcome back. Hopefully you watched my video, which was an introduction to the table method. And now what I want to do is actually go through an example of a linear programming problem. And I would like to show you how to actually create that table. So we're going to do the whole problem from start to finish. What I'm hoping you learn from this video is how to solve a standard maximization problem that's in standard form using the table method. All right, so let's look at an example. So what we're asked to do is maximize this objective function p subject to these constraints. Remember, these have to be not negative. X1 and X2 has to be not negative, and our constraints have to be less than or equal to 0. So the first step is to convert the system from an I system to an E system. Remember, to do that, we introduce two slack variables, S1 and S2. And then the next step is to create our table. So we know that we're going to have 6 rows in our table. We have 4 columns for each of the variables, x1 all the way to s2. And then we have the column for the objective function. So first we're going to fill in these first 4 columns. I've put these letters A through F on the left just so that we can talk about the different rows. So remember, this table is going to be our table of basic solutions. So the first thing we need to do, this is step 2 in the table method, is to create the table by introducing zeros, 2 zeros for each row. And we're going to write down all the different combinations. Remember, that means we have a 0 for x1 and x2, a 0 for x1 and s1, 0 for x1 and s2, x2 and s1, x2 and s2, s1 and s2. That's every combination. Now I want to walk through with you all the different, finishing this table. So I want you to understand where these different values are coming from. So we're going to do row A first. In row A, we are going to substitute 0 for x1 and 0 for x2 in each of these equations. When we do that, we find out these are both 0, these are 0. So we get S1 is equal to 21 and S2 is equal to 20. That's where these values for S1 and S2 come from. Okay, on to row B. In row B, it's starting to get a little bit more complicated. So we have a 0 for x1 and a 0 for s1, which gives us 2x2 is equal to 21. We have a 0 for x1, and that gives us 5x2 plus s2 is equal to 20. I did this on the next screen so that you can see where the values for x2 and s1 are coming from. x2 and s2. So remember, x1 is 0, s1 is 0. We substituted 0 for x1, which gave us the equation 2x2 is equal to 21. Then dividing both sides by 2, x2 is equal to 10.5. What we now do is take that value for x2, which is 10.5, and plug it into the second equation. And so when we plug 10.5 in for x2, we can solve for s2, which is negative 32.5. And we put that into our chart, into our table. All right, 2 rows done. We have 4 to go. So in row C, we have x1 and s2 are going to be 0. So for row C, plugging 0 in for x1 and 0 in for s2. Once again, I did this on the next page. Remember, we're substituting 0 for x1, 0 for s2 into these 2 equations. And solving those, I find that x2 is equal to 4 and s1 is equal to 13. I get the s1 value from plugging in 4 in for x2. So you realize I have to do this equation first, and the answer from this equation helps me solve the second equation. Take a minute to look at that. Pause the video if you have to understand where these values are coming from. So now I'm going to substitute 4 for x2 and 13 for s1 into our equations, into our table. All right, row D is next. For row D, we're using a 0 for x2 and a 0 for s1. Once again, here's the math. I'm plugging 0 for x2, 0 for s1 into this equation, these two equations. I solve for x1 first, which is 7. I substitute that into the other equation to find that s2 is equal to 13. And put that in the chart. Row E is next. And once again, I did this on the next page. So plugging those values into this equation, I find that x1 is equal to 20 and s1 is equal to negative 39. Again, stop the video anytime if you want to look at that, take a minute to absorb what happened there. And I substitute those values into my chart. Okay, last row, row F. So for row F, I am assigning the slack variables both the value of 0. To solve this now, so when I put S1 for 0 and S2 for 0, I have a system of equations, 2 equations, 2 unknowns. So I'm going to solve this using the methods I learned in chapter 4. So either elimination or substitution or Gauss-Jordan elimination. So use one of those methods. I chose to use the elimination method, and I multiplied the bottom equation by negative 3. And I found that x2 was equal to 3. And then substituting that back into one of the equations, I get that x1 is equal to 5. And I substituted those back into my chart. So these are all of the basic solutions. Now remember from the previous video, some of these solutions are not feasible. Which of the solutions are not feasible? Remember, you can't have any negative values. So anywhere you have a negative value, you are not going to have a feasible solution. So only rows A, C, D, and F contain feasible solutions. So once I have identified which of the solutions are feasible, I'm going to plug the values of x1 and x2 for those rows into the objective function. So you're going to do that one at a time to find out which of those basic solutions is going to maximize the objective function p. So remember, you're substituting those into this 10x1 plus 25x2. So you're going to plug in each of these values. You're going to skip row B and skip row E. So substituting those values in, we get these values for P, 0, 100, 70, and 125. Remember, we were being asked to maximize this objective function P. Maximize means find the maximum value. So the biggest number in this list is 125, and that's why 125 is our maximum value. So the maximum value is 125 when x1 is 5 and x2 is 3. Good job. See you next time.